Here I've got a couple examples that we're going to look at in terms of how to take an original function and find the formula for an inverse function. So one of the things you have to remember is that inverse functions use the idea of interchanging your coordinates. So if you started out as an x coordinate, an inverse, you're going to be a y coordinate. So you're going to interchange. That idea is used with the method that we have for going from a function to an inverse function. So essentially what you're going to do is you always want to make sure that you have an inverse function to begin with. What that means is that the very first thing you have to do with any problem you have is you have to determine if your function is one-to-one. If your function is one-to-one, then you have an inverse function and therefore you can find its formula. If you find out that your function is not one-to-one, in a lot of instances you could restrict your domain and force it to be one-to-one. Okay, and so that's just one part of math that we can use. Okay. Now, once you determine one-to-one or not, you follow three quick little steps in order to find that inverse function. First is you have to interchange your x and y in your original equation. Once you do that, you need to resolve your equation for y. Essentially, move all of your x's and all of your constant numbers over to the other side, isolate that y variable. Once you've done that, you just simply need to write in your inverse function notation and you're good to go. So let's go ahead and take a look at this one. So first and foremost, we need to sketch this graph in order to determine if it's one-to-one. Since this is in slope-intercept form, I'm going to go ahead and use slope-intercept form in order to sketch my graph. So in this case, what I know is I know that my slope is going to be 5, and I know my y-intercept is going to be the point 0.08. So I'm going to go ahead and graph that. So I have the point 0.08 here. And then my slope is 5, which is the same as 5 over 1. So remember, with your slope, you can either go up in the positive to the right positive, or you can go down negative to the left negative. So that'll give you in the same place. Because I'm up at the top of my graph, I'm going to go ahead and use the negative idea. So 1, 2, 3, 4, 5, and then over 1. So my next point is right here. And then to help make life easy just on myself, I'm going to use a straight edge. Obviously, you wouldn't necessarily have to, but it is something you could do if you want, or you could also input more points than just 2. However, keep in mind you are only required in most cases to use 2 points to graph a linear line. Okay. So now that we have our line graphed, we can go ahead and determine if it's one-to-one. The easiest way to do that is to look at the horizontal line test. Now in this, no matter where I were to graph a horizontal line, notice it's only going to pass through it once. So here, this is going to pass your horizontal line test. And so what that means is that this is a 1-to-1 function. And so the inverse is a function. Since it's a 1-to-1 function, we can go ahead and find the formula. So the first thing we have to do is we need to rewrite this in terms of x and y. So we have that this is y equals 5x plus 8. My first step again is to interchange x and y. So here this is going to become x equals 5y plus 8. Okay, so notice what we did is we interchanged x and y. Okay, so that was the first step that we did. The second step that we need to do is we need to solve for y. Okay, so here we're going to go ahead and do that. So here we're going to have x minus 8 is equal to 5y. Divide everything by 5, so I have 1/5 x minus 8/5 is equal to y. And then the last thing you need to do is you need to use inverse notation. So inverse notation just simply means your y has to be rewritten. So here you would have my function inverse is going to be 1/5 x minus 8/5. And this is what we were looking for. Okay? So in this instance, that's all that you would have to do in order to satisfy this problem. Alright, let's look at another one. So here we've got your rational. So I went ahead and I graphed it for you already. So here you can see this rational here this is your graph. If you were to again input your horizontal line test anywhere in it, one of the things that you will notice is you'll notice that this is going to pass the horizontal line test. Which again means that you have a 1-to-1 function, which also means that your inverse is a function. Because all of those are true, we can go ahead and we can find the formula. So just like before, the first thing we need to do is rewrite it in terms of y. So here we're going to have y is equal to 5x minus 3 over 2x plus 1. So that first step is we are going to interchange x and y. Okay. So here we're going to have x is equal to 5y minus 3 over 2y plus 1. Now what we need to do for that second step is we have to solve for y. So we're going to go ahead and start to manipulate this. The first thing you want to do is you want to multiply both sides of your equation by the denominator. So you're going to have x times 2y plus 1 is equal to 5y minus 3. You are going to distribute that x into your equation. So here this is going to become 2yx plus x is equal to 5y minus 3. We are then going to get all my y's to one side, and we're going to take this single x and move it. So essentially what we're doing is we're going to take this x right here and we are going to move it across my equal sign. Because it's adding, we have to subtract. And we're going to do the same thing. We're going to take this 5y and we're going to move it across my equal sign. Because the 5y is positive, we're going to subtract. So here we're going to end up with 2yx minus a 5y is equal to negative x minus 3. Here I'm going to pull out my y's. So I have a y here and a y here. So what I'm going to do is I'm going to pull this out. Basically it's the idea of de-distributing. So I'm going to pull out my y, or my common factor, and it leaves behind 2x minus 5 equals negative x minus 3. Now you need to get y by itself. So y is equal to negative x minus 3 all over 2x minus 5. Once you get down to that, the very last thing that we have to do is we have to use the inverse notation. So inverse notation is going to say that this is the inverse of my function at x is negative x minus 3 over 2x minus 5. Okay? And again, this is what I wanted. Alright, the last one that I wanted to show you is this one. And the reason I wanted to look at it is because of this piece right here. Okay, so here we have my function is 4x squared plus 3, but then we have this little where x has to be greater than or equal to 0. Okay, so when we're looking at this right here is a restricted domain. What this does is it allows you to say with confidence that you're going to pass the horizontal line test. Okay, so first and foremost we need to go ahead and graph this function. And so one of the things that we could do again is create an XY table. And so here we want greater than or equal to 0, so I'm going to start at 0. 0 squared is 0 times 4 is 0 plus 3. And then I'm going to have the point 1. So here this is 4 times 1 squared plus 3. So here 1 squared is 1 times 4 plus 3 is going to give you 7. And then maybe the point 2. So this would be 4 times 2 squared plus 3. 2 squared is 4 times 4 is 16. Plus 3 is going to give you 19. So in this case, I'm going to start out with the point 0, 3. So 1, 2, 3. And then here we're going to go ahead and go over to the point 1 and up to 7. So that's right here. I know it's a quadratic, so we're going to give it kind of a little bit of a curve and draw straight up like that. And so there is the function. Again, the restricted domain automatically tells you that you're going to pass that horizontal line test. So you're going to pass that horizontal line test. So this means that you have 1-to-1, which means that your inverse is a function. Now you may notice that I'm hammering that point in, but that's because it is extremely important that you understand what one-to-one functions are telling you. Now in this case, because it is one-to-one, it also tells me that I can go in and I can actually solve for my inverse. So the first thing I want to do is rewrite it in terms of y. So this is going to be y equals 4x squared plus 3. Again, that first step says that I have to interchange. And I'm going to interchange my x and y. So this is going to become x equals 4y squared plus 3. And now I need to go ahead and solve for my y value. So here I'm going to subtract that 3, so I have x minus 3 gives me a 4y squared. Divide everything by 4, so I have x minus 3 all over 4 gives me y squared. So I have to take the square root. Okay. So here I'm going to go ahead and take the square root. So this becomes the square root of x minus 3 over 4 equals y. Now, one of the things I want you to notice is that in general when we take the square root we always add plus or minus. Okay? So in this case there is something that you have to note here, and that is that due to the domain restriction we ignore the negative. So here the only thing that we care about is that this would just simply be the positive. Now since we know positive doesn't change anything, we generally don't write it. Okay. So the last thing that we have to do is we have to use your inverse notation, which is probably the single most important step. So this tells you that my inverse function is going to be the square root of x minus 3 all over 4. And there you have it. This right here would be your function. So there you have it. Everything that you need to know in order to practice finding the formulas for inverse functions. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video. I hope it helped to answer any questions that you may have already had, and I look forward to seeing you next time.